The time's just gone 9:15, so it's time for the Sandton Amateur Radio Club Bulletin for today, 15th of September 2024. Halfway through September and well into spring already. Well, good morning and a warm welcome. You're listening to the club station of the Sandton Amateur Radio Club, ZS6STN, which today comes to you from the shack of ZS6GM. The Sandton Amateur Radio Club Bulletin is broadcast every Sunday at 8:45 local time on the following frequencies: 145, 700 megahertz FM in the 2-meter band via the Sandton repeater, and on 115 kilohertz lower sideband in the 40-meter band from the shack of Knoll ZR6DX. There'll be a call-in after the tech topic this morning with reception reports and swap shop. Call-ins will be taken first on HF, then on 2 meters. In the bulletin today, a summary of the SARL news, club birthdays and club news, general ham radio topics of interest, and a call-in a swap shop on 40 meters and on 2 meters. Let's start with a summary of the SARL news for Sunday the 15th of September. RAE registration. The registration of the October Radio Amateur Examination closes at midnight on Friday the 20th of September. All registrations must be completed before this date, as no late registrations will be accepted. Clubs who are giving classes must make sure that all their candidates have complied with the required registration process, and this includes selection of exam center and call signs. Do it today. September Field Day. The editor of Radio ZS has received photos from the West Rand Amateur Radio Club with the promise of an article, as well as the Hibiscus Coast Amateur Radio Club, who's busy with their article. He's also seen photos of the Sasolburg Amateur Radio Club on Facebook, and there's a station in the Klein Karoo. What about other clubs and participants? If you participated in the field day, please send some photographs and an article in English or Afrikaans to the editor, Radio ZS at sarl.org.za. That's Radio ZS at sarl.org.za, to be received by Wednesday the 25th of September for publication in the October Radio ZS. The ARRL is testing AMSAT SA's Yagi for an educational project. 5. AMSAT SA dual band 2-meter 70 SEMS Yagis arrived at the ARRL headquarters this week for evaluation as a tool in an educational project. If the antenna meets the requirements of the project team, a large order may be placed with AMSAT SA, and the Yagi has been exported to radio amateurs in the USA, the UK, New Zealand, and Australia. Over 600 have already been supplied to local radio amateurs in South Africa and have been used for various activities, from communicating with satellites to fox hunting and tracking applications. The first South African version was a collaboration between Guy Eel, ZS6GUY, and Gary Immelman, ZS6YI, and was developed for YOTA 2018, where young people successfully use the antenna to operate satellites using handheld transceivers. For its size, the antenna has excellent gain, 4 dBd on 145 megahertz and 6 dBi on 435 megahertz. The Yagi is broadband with measured SWR almost flat over the entire band. The antenna is plug and play. No tools are needed except for soldering a connector to suit the application. It comes complete with a carry bag with full instructions and can be assembled and disassembled in minutes. Currently, SA AMSAT has stock. Visit www.amsatsa.org.za. That's www.amsatsa.org.za. Club news. The upcoming Sandton Power Hour Tech Talk, scheduled for 7 o'clock, that's 19 hours CAT, on Wednesday the 25th of September, will take place on Clint K6LCS, AMSAT ambassador and ARRL instructor and affiliated club coordinator, will be live from California. with an entertaining and interactive presentation on how to work amateur satellites with your handy talkie. You do not need 100 watts nor expensive antenna arrays to work the ISS and amateur satellites. SARL Awards and Trophies. The SARL members and affiliated clubs are hereby invited to submit nominations for the awards and trophies. The awards and trophies will be handed out at the 2025 awards dinner in May 2025. Nomination forms in MS Word are available on www.sarl.org.za /members/AGM/AGM members.asp. Well, if you didn't write that down, just go to the sarl.org.za, log in as a member, and go to the AGM tab. Please collect all signatures on one document, convert the document to PDF, and submit it to the Secretary no later than midnight on Friday the 31st of January 2025. And please use secretary@sarl.org.za. The only email address to use is secretary@sarl.org.za. Details of all the awards can be found on the SARL website. The editor of Radio ZS would love suggestions for the best article published in Radio ZS during 2024. Propagation report. Hannes Kutsia, ZS6BZP, reports that solar activity is expected to be moderate to high, and there are currently 7 sunspot regions with simple to complex magnetic configurations visible. There's a high probability for C-class and M-class solar flares. If you want to do your own predictions, the effective sunspot number for the week will be around 148. The 10 to 20 meter bands will be especially good for DX afternoons and early evenings, and the 6 meter band may also hold some pleasant surprises. So please visit spaceweather.sansa.org.za. That's spaceweather.sansa.org.za for further information. Now for the diary of events. Today, the 15th of September, is the ZS SOTA Spring Activity, 19th. Closing date for FT4 logs. The 20th of September, the closing date for RAE registration, and provincial schools also close on that date. 22nd of September is the Spring Equinox. 24th of September, National Braai Day and Heritage Day. 25th of September, the Sandton Power Hour Tech Talk. 28th and 29th of September is the CQ Worldwide RTTY Contest. 29th of September, the ZS1 QSO Party. 1st of October, Provincial Schools Open. 2nd to the 4th of October is Rosh Hashanah. And the 3rd of October, SARL 18-meter QSO Party. And the 4th of October, the closing date for the ZS1 QSO Party logs. Not to forget the AWA AM Valve QSO Party on the 5th of October and the SSB Valve QSO Party on the 6th of October. That concludes the summary of the SARL news. And now for the Sandton Amateur Radio Club news. Please have a pen and a piece of paper handy to note dates for your diary at the end of this bulletin. Firstly, member birthdays. We congratulate the following members on their birthday and wish them a blessed, happy, healthy, and successful year ahead. Albert Heisaman, ZS6 Alpha Hotel Yankee, is on the 12th. Bruno Antonio on the 9th of September. That's gone already, so happy birthday, Bruno, belated birthday. Lee Chapman, ZR6 Lima Charlie, on the 16th, that's tomorrow, and Neville Bussey, ZS6 Bravo November, on the 19th. Happy birthday to you all. SARL National Field Day Contest. Well, the Sandton Amateur Radio Club established its own field station at the Machali's Sleepy River Caravan Park. Many of the participants arrived on Friday and camped over until Sunday. And this year, Sandton had 5 operator positions scattered around the field and used physical separation to reduce potential interference between antenna systems. Earlier this year, during the first leg of the 2024 competition, ZS6STN took first place and is hoping to again take first place. Though winning is the final objective, what is just as important is to have a fun weekend out, and indeed it was. In order to maximize the 4 times multiplier, ZS6STN operated its various positions at 50 watts, and that required quite a lot of operator skill, especially to compete with DX and busy band conditions. The bands were very busy, firstly due to the All Asia contest taking place on the same day, and then the IARU Region 1 field day. Marius, that is ZR6 Mike Sierra, the contest manager for SARC, reports that we exceeded our previous contact count and managed 160 contacts over the weekend. Brandon, ZS6LZ, set up a 3-element wire Yagi antenna for 10 meters using 3 support poles, and results were excellent. And yes, that was that. And then club news and diary of events. So please grab that pencil and paper that I mentioned earlier and make some notes. So this weekend, the 14th and 15th, is SOTA weekend with lots of activations. You still have plenty of time left today to chase them. Next weekend, 21st, 22nd of September, is the Centurion Mini Train Festival weekend, and ZS6STN will be there with a field station. Come out, have some fun with the family, and maybe operate the station and tell the visitors to the train festival all about amateur radio. Then Wednesday, the 25th, is the Power Hour Tech Talk with Clint, KC6LS, who'll be live from California with an interactive presentation on Zoom, entertaining us with how to work satellites and ISS. Show him what a great South African amateur radio crowd we are. Then on Saturday, the 28th at 13 hours, is the Sandton Club AGM in Bryanston. If you did not receive your email invitation, please let the committee know on WhatsApp or email info@zs6stn.org.za. And if you are unable to attend in person, there will be a Zoom connection for you to participate. An online RSVP and proxy form are available, so please do go online on zs6stn.org.za and fill in the form. Then on Sunday, the 29th, is HF Assessment Day for RAE students, and this will take place at the home of Justin, ZS6JGP. RAE lectures are progressing well, with only 4 weeks to go before the final exam, so I hope you've been studying. 12th of October is Bakar Balloon Day, with 3 balloons due for launch from Secunda. Our very own Stuart, ZR1 Whiskey Tango, is finalizing a whisper beacon for the Planet Circumnavigation balloon. And Keith, ZS6HI, is working on the UHF SSTV system. Hope you get it ready in time, Keith. There'll be many payloads, including 3 repeaters, LoRa beacon, VHF and UHF slow scan TV payloads, APRS, and several others. So keep an eye out for bulletins and watch Radio ZS. Even if you can't go to Secunda, you can still participate and make use of the payloads. Well, that ends the Sandton Amateur Radio Club Bulletin for today. Up next, regular technical discussion. But first, I'd like to turn it over to our chairman, Keith, ZS6HI, ZS6GM.
Good morning, Chris, and good morning to everybody on frequency. Thank you very much for Bulletin so far. Well received, Chris. You've gone through most of the club activities, so that's great. I'd just like to really encourage people to come out to the annual general meeting on the 28th at 1 o'clock in Bryanston. This is our award event, our club social event, and obviously we get through the AGM mechanics as well. And then just to give you a little bit of feedback in terms of yesterday and today is the SOTA weekend, and there were a number of operators out yesterday morning, even though the temperature was pretty high in the early 30s, 33 degrees I believe it was yesterday during the course of the day. And I know that both Mark, ZS6MDX, Matthew, ZS6MDV, Quinton, ZS6QVB, they were all out, as well as myself, manning peaks, and it was a really fun time just to make all those summit-to-summit contacts. And the guys were out there, and ZS6 Lima Zulu was also out there yesterday and did 2 peaks. Wow, Brendan, you running around a little bit. I know that Brandon was going to do 2 peaks today, but he's been taken ill, so get well there, Brandon. But there are a number of peaks being activated this morning as well, so please be great chasers and get them into your logs. Chris, I think that's really all that I would like to broadcast. If anybody has any questions or any suggestions, or please do send them through to info@zs6stn.org.za, or post them on the WhatsApp group or directly, and we will then get those answered. Thank you very much, Chris. ZS6STN, ZS6HI.
It's time for today's technical topic, and today's technical topic is all about HF propagation. Ionospheric propagation is the main mode of radio propagation used in the MF and HF portions of the radio spectrum. So what is the ionosphere? Well, it's a series of belts or regions of ionized particles in the Earth's upper atmosphere. Height varies from 80 kilometers to more than 300 kilometers. There are 3 main regions of interest to us radio amateurs, and they're the D region, the E region, and the F region. So a quick summary: the D region is the lowest, and when a sky wave leaves the Earth's atmosphere and travels upwards, the first region of interest is the D region, which is at a height of between 60 to 90 kilometers. This region attenuates signals as they pass through, and the level of attenuation depends on the frequency, with low frequencies being attenuated more than the higher ones. And of course also the D region disappears at night when there's no sun's irradiation. So that's why you can talk much further on low frequencies at night. Then there's the E region. Once signals have passed through the D region, they reach the E region, which is at a height of about 110 kilometers. And although this is still, there is still some attenuation, this region reflects, or more correctly refracts, signals, sometimes sufficiently to return them back to Earth. The level of refraction reduces with frequency, and therefore higher frequency signals may pass through the region and on to the next one. The E region is of great importance for the lower end of the HF spectrum and even into the MF spectrum. So top band, 160 meters, the E region plays a big role. Then there's the F region. This is the one that enables long-distance HF propagation for worldwide communications. Signals that manage to pass through D and E regions will reach the F region, and again this acts to refract signals and they can be returned to Earth. During the day, this region often splits into 2, known as F1 and F2, and they're found at altitudes between 300 and 400 kilometers above the Earth in summer, and in winter months they may fall to a low of 200 to 300 kilometers. At night, the 2 layers generally combine to form a single layer, and this is generally at an altitude of 250 to 300 kilometers above the Earth. Just remember that these figures are only a rough guide, because they will change considerably depending on the time of year and the state of the sun. Right, sky wave, skip zone, and skip distances are 3 key concepts. And they show why radio communication signals are heard in some places and not in others. The sky wave refers to a signal that travels away from the Earth's surface towards the ionosphere, unlike a ground wave that follows the contour of the ground. The angle between the line of the sky wave signal and the Earth's surface at that point may be shallow or steep. This is known as the radiation angle or takeoff angle. Skip distance is the distance over the Earth's surface between the point where a radio signal is transmitted and the point where it is received, having traveled to the ionosphere and been refracted back by the ionosphere. So, skip distance is dependent on a variety of factors. Firstly, frequency. The frequency of operation has a major influence on the skip distance, and typically as the frequency increases, a lower angle of radiation is needed to return signals to Earth in a shorter distance. Also, higher frequencies tend to be reflected or refracted by higher layers or regions in the ionosphere, and this will lead to higher frequencies having a longer skip distance. And it's all about geometry, so do some triangulation from your point up to the ionosphere and back to the Earth. Just remember, of course, that you do have the Earth's curvature. Then the ionospheric conditions play a major role in governing skip distance. Under some circumstances, when ionization levels are high, it may be possible for signals to achieve very short skip distances. And then the angle of radiation from the transmitting antenna will also have an impact on the skip distance. A lower angle of radiation will lead to longer skip, and this means that radio communications links can cover greater distances if low angles of radiation are used. So that's why takeoff angle is so important, and using a vertical or a beam high above the ground will give you lower takeoff angles. As the frequency is increased further, the signal is refracted less and less by the E region and eventually passes right through to the F1 region. And it may be reflected, passing back through the D and E regions to reach Earth again. HF propagation and frequency selection. This is important. One of the key aspects of HF propagation is to use the right frequency. It may be possible for propagation to enable communications to exist with one area but not with another. Because the higher frequency signals can pass through the lower regions, signals on different frequencies will travel different distances. And when using HF propagation via the ionosphere, as the higher frequencies tend to be reflected by higher regions, they're able to reach much greater distances as a result of the geometry. Think triangulation again. Right, there are a few definitions that are used within HF propagation circles. Firstly, there's the lowest usable frequency, which is the lowest frequency at which the received field intensity is sufficient to provide the required signal-to-noise ratio at a specific time. And ALS is another term that's used, which is the absorption limited frequency. And LUF and ALS are roughly synonymous. Now you'll find that you can get charts of ALF from various propagation websites. Then the maximum usable frequency is the highest signal frequency that can be used for a transmission between 2 points via refraction from the ionosphere at any given time. And then the critical frequency is for a given layer or region in the ionosphere is the highest frequency at which a signal traveling vertical upwards is reflected back to ground. This gives a very good indication of the state of the ionosphere. NVIS is the near vertical instance communications and depends on the critical frequency. So NVIS is dependent on the critical frequency. Then optimum working frequency, that's considered to be the highest effective frequency that's predicted to be usable for a specific path and time of day for 90% of the days of the month. So usually when you're looking at choosing the best frequency or the best band, you'll look for the optimum working frequency. Ionization is chiefly caused by UV radiation from the sun. As a result of the state of the sun and the radiation received from it governs the state of the ionosphere for HF propagation. So what about sunspots, sunspot cycle, and sudden ionospheric disturbances, SIDs? And we had one of those yesterday that just about wiped out the 40-meter band. Sunspots are areas on the surface of the sun that are a little cooler than surrounding areas, and their presence leads to higher levels of radiation being emitted, and therefore this affects HF propagation. Sunspots have been recognized on the surface of the sun for many years, and there is a correlation between sunspots and conditions for HF radio propagation. SIDs, or sudden ionospheric disturbances, is the result of a coronal mass ejection, also known as a CME, and has a major effect on HF propagation conditions. The number of sunspots on the sun's surface varies. On some days there are few or even none, whereas at other times there are many. The daily sunspot number varies considerably over a short period of time as the sun rotates, But if the smooth sunspot number is used, it can be seen that there is a much longer-term trend. This trend shows the number of sunspots rise and fall over a period of approximately 11 years, the so-called 11-year cycle. This number, though, is only an approximate guide because there's quite a bit of variation. Sometimes it can be 10 years, sometimes it can be 12 or even 13 years. The increased numbers of sunspots mean increased levels of radiation, and in turn means that there are greater levels of ionization in the ionosphere, and this affects propagation on the HF bands. At sunspot minimum, frequencies of around 15 to 20 megahertz are normally supported during the day, and at sunspot maximum, frequencies in excess of 60 megahertz may be affected. Now we talk about during the day. So we're talking about daytime is when the sun is visible over the point of reflection. So you've heard of gray line, and gray line is where the propagation occurs between a sunny part of the world and a dark part of the world. So just remember, daytime or nighttime refers to at the point of reflection. Solar flares are enormous explosions that occur on the surface of the sun, and they result in colossal amounts of energy being emitted. Larger solar flares eject large amounts of material in the form of protons. Flares erupt in just a few minutes with apparently no warning, and when they do occur, material is heated to millions of degrees Celsius, and they leave the sun in a huge arch, returning sometime later. So they go out like a boomerang and come back in. Coronal mass ejections, CMEs, are another form that can affect radio comms. And although much greater than flares in many respects, CMEs are huge bubbles of gas that are threaded with magnetic lines, and the bubbles are ejected over the space of a few hours. CMEs can give rise to ionospheric storms, and these can provide short-lived enhancement to the ionospheric radio propagation conditions, but before long can also result in a blackout to radio comms via the ionosphere. SIDS, or sudden ionospheric disturbances, cause a number of types of blackout on the HF bands and last for a few hours, but they may be a precursor to a longer blackout. Generally, a SID is caused by large M or X-class solar flares. So when you're looking at spaceweather.com or one of the other sites and you see large or M-class flares being predicted, that is generally a sign of an SID. Along with the flare, there's a massive increase in the level of radiation emitted by the sun, and it can just take 8 minutes for radiation from the sun to reach Earth, at which point the effects start to be noticed. As light takes the same time to reach Earth, there's no prior warning of this event. During the SID, lower frequencies will be severely attenuated or may be completely wiped out. Often, background noise level will rise to quite high levels, and that's what we saw yesterday on the 40-meter band. Then the indices, K and A indices, are regarded as geomagnetic indices, and they measure fluctuations in the Earth's magnetic field, which are influenced by solar activity, but are not direct measures of solar phenomena themselves. They're tied to specific geographic locations, so you should look at Hermanus K and A indices for South Africa if you're doing your predictions. The indices have a range from 0 to 9 and are directly related to the maximum amount of fluctuation relative to a quiet day in the geomagnetic field over a 3-hour interval. The higher the number, the greater the effect of the geomagnetic flux on wave propagation. Sunspot numbers and solar flux. Well, the solar cycle varies over a period of 11 years from trough to peak and then back to another low. The conventional index of a cycle is known as the sunspot number, which is defined from observation of the sun by telescopes. This index can be defined on a daily basis, but is more normally averaged over a month or even a year. The yearly average is mostly used as an indicator of the progress of the solar cycle. The sunspot number can be compared with ionospheric maximum frequencies and can be used as a predictor. The ionosphere responds to more than just sunspot number, and geomagnetic storms can also affect the ionosphere. Also, the EUV flux from the sun, which actually produces the ionosphere, does not necessarily vary in exact accord with the sunspot number. So the solution is to use an ionospheric index, which is known as the T-index. It was derived in Australia, and it's derived from observed values of maximum frequencies. The T-index can be best regarded as an equivalent to the sunspot number. The sunspot number would best match the observations made by the ionosphere and more accurately reflects current conditions. So that's the talk for now. I am going to give you a couple of interesting pointers. So write these down. Firstly, there's an excellent article provided by Duron Tull, 4x4 X-ray Mike, entitled Quick Guide to HF Propagation Using Solar Indices. That's on QSL.net, looks for 4x4xm. And then one of the most useful sites I've found, particularly as it applies to the southern hemisphere, is the Australian Space Weather Centre, and that's sws.bom.gov.au. So that's www.sws.bom.gov.au. That's the Australian Space Weather Centre, and they collaborate with our own sensor and the Southern Hemisphere information from the Australian Space Weather Centre is very applicable and very useful. They also have a number of propagation tools that you can use for real-time propagation based on the current A and K indexes and the current T index. So that's somewhere you should go. Well, that wraps up our Tech Talk for this morning. A recording of the Tech Talk will be made available via the ZS6STN YouTube channel, and also a text version will be made available. I'll be sending it across to Keith, and he might want to even include it in the dipole. So this is ZS6GM, bringing the weekly club bulletin and Tech Talk to a close for the Sandton Amateur Radio Club, ZS6STN. We thank contributors and any relay stations. Your input is invaluable. And if you'd like to have some more information, like to join the Sandton Amateur Radio Club, then please drop us a line to info@zs6stn.org.za. info@zs6stn.org.za. Love to hear from you, and we'll get back to you. This is ZS6STN, operated by ZS6GM. We now relinquish all frequencies for general use.